Alright, welcome to the second video for week 6. In this video, I want to show you, well, to start, I'm going to show you a very simple model that we can use to help estimate whether or not a client is going to run out of money. Now, I talked to Harry about this, and I'm sure you guys are going to have a lot more data than what I can show you here. Probably some longevity tables, things of that nature. But nonetheless, you'll just have more data to modify your models a little more precisely for your clients. But here's the basic idea. So let's start with a client, and let's just say the value of their portfolio is $1 million, and this is, at year 0. Okay? And, obviously we're trying to see, how much money this client's going to have. So here, the returns are, normally distributed, are normal with, a mean of, 0.05 and a standard deviation of, say, 0.03. Okay, so we've got to model the returns, right? All right, but we also have to model the withdrawals. So, the withdrawals are uniformly distributed, say between 50,000 and 70,000. Okay? All right, so we start off with $1 million. So what I'm going to do, move that down. Okay. So will this client, have enough money after 5 years if they're taking out between $50,000 and $70,000 a year? All right, well, let's find out. So let's get this all set up. Whoa, here's year 5. Okay. All right, so I'm going to break this down into 2 pieces and then combine them. So how do we want to think about this? Well, the first thing is, what will be the value of my portfolio at the end of, say, year 1? So that is just going to be, right, what I started with, multiplied by the return that I get in year 1. Well, that's going to be the 1 plus, right? And then I have to simulate the return. So that's what I'm going to do with this. So I'm going to get my norm.inverse function. Again, the probability is the RAND function. The mean we said is 0.05. Standard deviation of 0.03. Okay. Yeah, I know. I need another parentheses in there. There you go. All right. So, this client, given these parameters, at least in year 1, would have made $59,000. All right. Now we need to also model the withdrawals. So that's going to be that formula I gave you from last week. It's the one that's in your book. And so this is going to start off with the 50,000 plus RAND times the 70, 1, 2, 3, minus the 50, 1, 2, 3, right? And so this client would, spend $66,000. So what will this client be left with at the end? Well, it's just going to be the difference between these two. And so at the end of year 1, the person would have $972,000. Yes, I know that we're not even worried about the timing. When did the client withdraw money? Right? That's a much more complicated problem, right? Let's just, everything happens, say, at the end of the year. The client gets his return and then spends all of his or her money, right? You need to be honest with you need a much more sophisticated program to do that. Or you could do an Excel, but it would get hairy because now you might be looking at monthly returns and monthly withdrawals and stuff like that, right? So we're just keeping it simple in this example. Okay, So what I'm trying to drive at here is this is the bottom line. All right, this is what you want to do. But we want to simulate this, right? This is the number that we want to simulate. And then we're going to do the same thing for year 2, year 3, year 4. Well, I have an easier way to do this. At least I think I do. And I would encourage you to think about it this way. So what I did here is I broke out, my expected returns plus my withdrawals into 2 cells so that you could see what I was doing. What I would actually recommend is you just put everything into one cell. So I'm going to go back here, and to do this, just put parentheses around all of this, okay, and then subtract from that my withdrawals. So this is just going to be the 50, 1, 2, 3 plus my RAND times my 70, 1, 2, 3 minus my 50, 1, 2, 3. There. So I'm putting everything into one cell. Now the reason for that is now I can just copy this down and that will generate all of my trials. All right? And so voila. Now I don't need this, I don't need that, and there you go. So after, this is the first trial. After year 1, this client would have roughly about $1 million. Now the nice thing about doing it this way is, right, I can just copy this thing over and presto, I'm done. There you go. So watch. Oops, sorry. Let me move this to the right so you can see it a little better. Right, but year 5 says, okay, take the balance from year 4, multiply it by my expected return. That's the norm, normally distributed random variable, blah, blah, blah. And then subtract from that what my expected, monthly or yearly annual expenses are going to be, and presto. So I'm done, right? Now all I have to do is copy this down to replicate all of my simulations. So now this, you do need to include year 0. Right? So I'm just going to copy. All right, and then, I don't know why I did that. Page down. A little more than that. There we go. Oh, it's 500 more, at least. Hit paste. Sweet, and nothing happens. All right, Excel. All right, so copy. Okay, paste. Oh, there it goes. All right, stupid machine. All right, well, there you go. So now in this problem, you are going to run all of your summary statistics on year 5, right? This is the year, right? And I know I've only went out 5 years. Obviously, you could go out more than that. But you're going to run, the mean, the standard deviation, the min, the max, the number of losses, and the percent losses on your year 5 numbers, right? Because this is where you want to make sure the client has enough money, right? This is the client's final year on planet Earth, and you want him or her to have enough money, right? So that's the year that you run all of your summary statistics on, right? And obviously, in this case, you're hoping that, the min is greater than 0, i.e., there are no simulations in which you run out of money in year 5. Okay, so here is the basic model that we can use to determine, will a client's portfolio last his or her entire lifetime. Now, obviously, in the real world, 5-year horizons probably aren't going to cut the mustard. But, obviously, the way this is set up, you can copy this out for many, many years, right? I just don't want to. My goal was, here's the basic setup. you can just copy everything, 10, 20, 30 years, whatever you want to do. Okay, so with all that said, here's the basic setup. So in the next video, what I'm going to do is kind of do the same thing, but now let's, I don't want to say complicate things, but let's add some things to this model that will enhance what we're doing for the client. All right? So that's in the next video.